want to talk to everybody today about some high voltage leaching. It sounds weird, it acts really weird, but it'll change your whole project if you don't take it into account. What's usually the culprit in this? See this little bar here that we all tend to use? Well, this can be your biggest enemy or greatest ally. It really depends on how you want to use it. So, because this is set up and it's independently for each one, there's no question about that. It's not that it ties in there, it's the products that you're dealing with. So, we'll just do a small one here. There we go. There's our little bar here. No problem. Here's the issue. I am going to put in a DC flyback. I'm going to run my negative here. I'll take my positive and put it here. Now, what am I doing in here now? This area right here will now have a field around it. Anything that I add here will be in that field. Therefore, you're going to get a leaching that's going on. It will pull the frequency in there. It'll drop one, it may raise the other. Now, what happens when I go over here, and that's my Tesla coil, and I do this. I come over here, and I put it in there. Now, I haven't even connected it to anything in my device, but I already have one field from this. That's field 1. This is field 2. I now have another field. I have this field for my Tesla coil. I have this field for my high voltage. Now I need to start adding things into this. If I want a bigger bar, you can see where this is going to go. Say I want a motor right here. I simply just want to drive something. Well, I'm going to connect it in here, right? With my positive and my negative right here. And then I'm going to connect this to your power source. What happens now? This field, because it's right here, expands over this. This field expands over this. You see where I'm going with this? What happens to my motor? You will get a change in speed. What happens when the Tesla coil itself is stronger than the high voltage? Then you will get the Tesla coil feeding into the high voltage. If this is at 16 volts and 0.12 amps, which is stronger? Well, it's obviously that our Tesla coil is stronger than our high voltage, isn't it? So what happens? The Tesla coil itself, the frequency right here, now feeds into the frequency here, but it is also feeding in to the frequency here, which is the RPM of the motor. Can you see how this becomes a problem? If you're not accounting for this, this is going to redirect all of your systems. based on this little bar. Because you're not realizing the Tesla coil has a field, the high voltage has a field. Now, what's the problem here? If this is a Slayer, the biggest problem with the Slayer exciter circuit, or the greatest advantage, depending on how you see it, it self-corrects. What does that mean? Anything that's in the field of this Tesla coil, it will change its frequency based on every component that you place into it. Anything that you attach into this bar, it will now adjust its frequency to it. Let's look at this in operation so that we can see an example of where this can mess you up or take you over the top in understanding this. Now, this is our simple Graviflyer project, right? We have this connected to here, this connected to here. And then we have rotating discs in two directions. Now, what's at the bottom right here? Yeah, you guessed it. What is the one thing that everybody takes out when they build this project? This right here. What does that do? It leaves a loss in the system. You see, we're not reverse engineering at that point. We are now engineering our own model when we took this part out. But this part so happens to be one of the most important parts of the whole system. You have up here your piezo disc, which is constantly on. The button you push right here is an off button. It's not an on button, it's an off button. This is constantly on, putting pressure on this. It's when it releases this center plate, the negative down here and the positive here, this will now change. It'll pop the plate, and I'll just draw like that, where now this will be positive and this will be positive. Just understand that, that's separate from this, but let's get back to this, right? We want to look at this. We have motor wires. We have motor wires, right? Each one of them goes to control 1 and control number 2. In Alexi's case, there was only one control, which now it makes sense because he's fixing the motors based on the Tesla coil. I know it doesn't make a lot of sense yet, but he does, because it all self-corrects. Now, what do we have right here? This is attached to our Tesla coil. These two plates right here, but that doesn't go directly there, does it? No, it doesn't. You see, he put it there, and then it goes there. Over here, we have our high voltage. Again, positive here, negative here. But it doesn't run directly to it, does it? Now we should start to understand something. All of this has been driven by this for one reason. Your Slayer exciter circuit is self-correcting. That's a real kick in the teeth for everybody who's done this project. This right here is the difference between the frequencies being right and the frequencies being wrong. Typical oscilloscope reading. Like this, and though I drew them wrong to each other, they're all the same, okay? What happens when you don't have this? You get this garbage. This right here ruins your project. You cannot put it in the correct harmonic with an off frequency happening all the time. It will ruin the harmonic in the whole thing. This right here is not being mitigated out. This right here is the same. So you can see the Slayer is doing its job even if this part isn't in there. But in order to get rid of this, I need this. I need it to work in this circuit now. You see, there's something about a Slayer exciter you should know. If you have your power source too close to like a PNP or an NPN circuit and you have a big field going on, your power source will do something funny. It'll go up to about 8 to 10 volts and then it'll stop. Why? The field itself from your coil has now come into your power source. So what'll happen? You'll start cranking up that power source, but nothing's happening in the field. And then all of a sudden at 20 volts, boom, your field jumps, right? And you get this massive surge of power. Why? Because the Slayer is trying to tune itself with your power source. It's trying to tune itself with your Slayer exciter. You see, you have them too close, you'll start to notice that. It's an anomaly. But it comes into play here because of this. That's what high voltage leaching is. It's a self-correction method. It's the Tesla coil trying to correct everything in its vicinity. It's taking the motors, it's taking the high voltage, it's taking all of it. Why? Because the power of that Tesla coil is 10 to 20 to 30 times greater depending on your input than any of the rest of them. So it's going to overpower systems. Not to mention the field itself that you're growing. You see, you think you're just growing it on the plate and at the Tesla coil itself, right? Well, no, this little bar has a Tesla coil field on it as well. It's putting it over the whole thing. It has its own field over it. That's the self-correction of this. This right here is your Tesla coil coming through on your center plate, which is not a problem. This right here is a self-correction you need to eliminate that. That's what this is. You cannot let it be individualized in this project. That Tesla coil must take over and it must self-correct everything. Again, Alexi's device is self-correcting. That's why it works so well. This is something that we've all done. I don't know how many times I say this, and I am 100% guilty of it in this one right here. Do not change the way the inventor built it. When you're reverse engineering, every single part has to be the same. I thought I knew better. I ran wires straight over to motor controllers and everything else separate from this. What did I do? I ruined my project. I wasted months and months trying to figure out the frequency in this thing. I basically ruined my project because I did not reverse engineer it the correct way. Now that I know it, I go back and add it in the correct way, and what happens? They balance perfectly in the same spot now. I do not have an issue anymore. My motors now change speeds like they're supposed to in resonance. You see, it's not picking up one-to-one resonance. No. You always look at it and you go, okay, that little piece of twine, when you move it, and you go, there's one, right? Then you move it a little closer and there's two. You move it a little closer, there's three and four. You see, you got to keep doing that. And then your RPM itself is the frequency. So now you can understand it. You're not 1-to-1, you're maybe 20-to-1 or 200-to-1, but it falls in that same frequency line. And because of that, it all works in conjunction together. It's the way harmonics are built. That's why this thing's doing that. That's why once it's up in the air and it's running, it can stay up there and you can start messing with it. It won't do anything because it's always self-correcting. This right here is the biggest failure I've made. I learned everything about a Tesla coil until I ran into this and it started messing with my power source and I wanted to know why. And there's my answer. In order for the motors, the high voltage, all of it to be self-correcting, the Slayer exciter has to be dominant. That means the voltage in my high voltage at 16 volts and 0.12 amps or whatever it was, it means now this number makes a whole lot more sense, doesn't it? It didn't make sense before. Why does the high voltage just have to be there? I don't understand. It's ionizing the air. We know that. We know that it's converting it. It's getting rid of everything else in there to create an ionized field inside that bubble. Why does that make sense? Because it takes 10 minutes to get it all in there. Where you can take two DC flybacks, put them together, and then you can get it done in less than a minute. But this has to make sense. So why would he do 10 minutes to do it? Because his Tesla coil is dominant. His Tesla coil had to convert everything in there to work. And if this number's too high, it can't do it. It can't overcome it. Interesting, isn't it? The one thing that we all think we know better, that we want to change something in our project, could be our greatest failure. Should really learn each system and why they're doing what they're doing. Now that we understand this, we can reset our project to get it going. High voltage leaching is a problem. Eric Dollar talked about it himself. You have different systems. Frequency wants to get in balance with each other. And when you have a self-correcting system like a Slayer exciter, now you can understand why. It is a massive understanding to just know this one little piece that was the bane of my existence for the last several months. Now I got it corrected. Funny how that works, huh? All of this work for that. One of the things, I'll just go over with it because I shared a little earlier, so let me just finish off the thought here for you. So you got a piezo disc, right? And in this little disc that comes out like this, how does it work with your Tesla coil? Well, let's draw a little Tesla coil over here. You see, if you've ever done this test and you've taken this and it run it through here, you'll find out that there's only one frequency when you put this in here, and it's connected to, just put it right here. This is our, they call it an ultrasound, okay? But really what it is a jewel thief circuit. When you put it in there and you have this little button here, okay, you have a dial and you have a little button. And as you push this button, it breaks the negative in it. And what it does is it shuts it off. And then it'll turn it back on once you let off the button. It's a shut off switch. What does that mean it's doing? It means that it's always doing this. It's always transmitting. So what happens now when you turn it off? Turns off the transmitting, but because this thing is a transmitter, but it's also a receiver, so it's a transmitter and it's a receiver, it now takes in all the frequency from the entire craft. Right? Now it takes it into here, we turn it back on, boom. You don't realize it, but you just switched the entire frequency of this thing to whatever it's working at. Now it directly affects the field that's around here. This whole understanding of this is crazy, because I always wanted this thing not to shut off the power, I just wanted it to give me the boost, right? That's all we thought it did. You push the button, it gives you a boost of energy and it starts working, right? But no, it's in reverse. It shuts it off so that this process can happen. Once this process can happen, then you're pushing out more power. What happens to everything when you look at your frequency? Say your frequency's here, what happens? All of these now spike on your oscilloscope just like this. What did you end up doing? You just doubled it right here on every one of them. Why? Because it picked up all the energy from being a receiver and now retransmitted it back down. Therefore, it amplified the total amount of energy going through it. This is proven. You can see it on your oscilloscope every time you do it. What does it also tell you? In this thing right here, it's a jewel thief. Therefore, you have a toroid. Has a wire around it. Okay? 22 windings. $11 windings on each side. There's only one point in this whole thing that will allow this right here to work. Just one. Just one. One spot. What is it an indicator of? You have your dial here. There's a spot right here where we get a ring. There's a spot right here where we get a ring. But the spot we need is right there. You hear it. It sounds like an ultrasound. Okay? It pings like it would like an ultrasound in water. That's what it's doing. This right here is the sweet spot. Why does he have problems finding it? Because he hears this, but he knows he needs this. He can't pinpoint it every time. And you wonder why? It's because of that. That very reason right there. Because you'll hear this, but you hear nothing here. But it's the amplification portion. That's what that jewel thief is doing. That's how it's working to amplify it in this whole process. Now with that understanding, hopefully the people building this whole Graviflyer situation can fix it. The first thing you need to understand was the leaching. The second thing you need to understand is what the piezo is doing. Now, with this said, we get into the very concept of this. And if you deal in static electricity, okay, or you deal in a lifter, this is why it's so important to understand this. There's two processes to a lifter. One is ion wind. Okay, that's pretty simple. You build your little craft here. You have your skirt on it. You see it. You get the air flowing here from your high voltage side that's up here. And it's doing this. It's blowing it down just like that. That's the ion wind craft, right? We are all aware of this one. What if I change it? I'm just going to build this like this. Okay? Now, sorry, I didn't draw it very well. I have this craft. This is all solid in here. This is not open. Well, you say I got ion wind and it's coming through here. Well, that's not going to work. It's not open. Yeah, it is. It's going to work. Why? Because it's a different process. I'm going to push a signal down here. It's going to hit it here. And then this is going to force the direction up. This is 1,000 times more powerful than this lifter right here. This carries weight, this does not. Okay? This is 2.4 meters per second is what you're going to get here. You're not going to overcome that and put weight on it. You have to understand this. Let's draw this a little better so we see it in a different way. If I simply have a disc here, and I'm pointing it down, right? This would come up here and cancel it. This over here is pure lift. So what does that mean I need to do? Well, let's just change the whole system here. I'm now going to raise it, but now instead of all these canceling out, that's all that's canceling out now. They go, well, heck, man, that left me with an incredible amount of lift, didn't it? The understanding of this versus this. How do you see this real easy? Take a small plate, take a bigger plate, just put paper in between, then hit it with high voltage. This will always attract up as this attracts down. And it'll show a difference on a scale. Isn't that amazing? This right here is the correct way to lift something. This right here is the incorrect way to lift it. This is the difference between a simple ion wind lifter and the correct kind of lifter for weight. If you deal in static electricity, you would already understand this. This is 10 times the power that this is. This is 10 times the hardness in a scale to pull off than this is. But this allows you now to take the voltage from here from what would probably be, what, 60,000? You can go to, you know, probably 210 or more. If you can get it up there, man, go for it. But you can add more power here, because you can take the distance and move them apart but get the same process. For those of you who watched my channel before, how do I know this? How in the world would you ever figure that out? It's a simple little test. You have two plates here, right? You just have a piece of paper in here. This right here is non-conductive. But in static electricity, it's semiconductive because it hits the point of saturation. The entire thing saturates. And then it'll go up and lift. They say, well, that sounds a little backwards, right, from what you just said. Yeah, but this is where the anomaly comes in. If I flip this thing upside down and I wire it correctly and put this in the correct dimensions perfectly, again, you have to put it in perfectly, because I changed the area right here, right? I changed my complete area in doing this. In order to get this to work, you must now change your area. Now, everything goes up as the force of pressure goes down, and we changed it. That's the paper lifter experiment that I did. It's static electricity. It's an understanding of how it actually works. It works the same as a lifter. This is the process with the piezo buzzer. When you get into Alexi's project, if you've done this, you already understood it. Then you can apply it. That's why the piezo buzzer works. It's just taking that center disc and it's flipping it. And I drew it with a squiggly line before, so let me validate what that is. Here is your plate. It's all negatives on the bottom. It's all positives on the top. You must now change this all into positives. How do you do that? You need to wobble the plate. What is the piezo doing? It's applying pressure at all times, but the pressure is not great enough to flip the field. But remember, we picked up power, okay? We picked it up because it's a transmitter and a receiver. We more than doubled our power. What happens? This whole plate gets rid of this and takes on this. Your plate that's above it, we'll just draw that in here, is going to pull a negative on it. Now it has a direction to go. That's how it works. It all comes down to this stupid thing, the bane of my existence. I couldn't get the frequency right. You get the thing to start to put in the power, puts it in, and beautifully expands the power. It's pulling the energy from the ground in a cold energy circuit. If you didn't understand that, go back and watch my one-wire energy experiments on my Tesla coil. It's pulling the energy from the negative and it's pulling it from the ground itself because it's a heat source in a cold system. Therefore, it changed the whole understanding of it. That's why I had to be on the ground. I couldn't be in the air. That's why it sparks when it's on the ground. You get this stupid thing to start lifting and a rogue frequency sets it off and puts it all out of balance. This corrected it. It's only a matter of time now before that thing starts to fly. Once you start seeing it lift the legs, you know you're almost there. Fixing this is going to put it up in the air. Anyway, I hope you guys understand this. This is leaching. This is what it does. It's pulling frequencies when you're not aware of the fields that you're putting into it because they're high voltage.
The old man builds. The old man builds. The old man builds. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.